Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of trigonometric functions. So as per the problem, evaluate the 6 trigonometric functions of theta. So let's analyze the given diagram. As per the diagram, angle theta lies in quadrant 4. We are given the terminal arm for the angle and point 24, -7 lies on this terminal arm. We'll use this point to find the value of the 6 trigonometric functions of theta. The 6 trigonometric functions are sine, cos, tan, cosecant, secant, and cotangent. So the first step is to draw a right angle triangle using the given point with the positive x-axis. The right angle triangle will look something like this. This bottom corner is the point 24, -7. In this triangle, the length of the horizontal side is 24 units because 24 is the x-coordinate of the given point. The length of the vertical side is 7 units because -7 is the y-coordinate of the given point. We will use this red angle in this triangle to evaluate these 6 trigonometric functions of theta because this red angle is the reference angle or the related acute angle for the given angle theta. This is a very important concept we need to understand and memorize to solve this type of problem. Next, we should find the length of the third side in this triangle, which is also the hypotenuse in this triangle, using the Pythagorean theorem. So let's start by writing the Pythagorean theorem equation. In this equation, C represents the length of the hypotenuse, A and B are the lengths of the other two sides of the triangle. Now we can apply square root to both sides. So the length of the hypotenuse is 25 units. Next, we will use the cast rule, also called the ASTC rule or the all sad turtles cry rule, to find the value of the 6 trigonometric functions of theta. I'll write the names on the board. This rule is used to find the sign of a trigonometric function in the 4 quadrants. We can label the 4 quadrants in the diagram as in quadrant 1, all trigonometric functions have positive value, so that's the quadrant with letter A. In quadrant 2, sine and cosecant functions are positive, the other functions are negative, that's the quadrant with letter S. In quadrant 3, tan and cotangent functions are positive, the other functions are negative, that's the quadrant with letter T. In quadrant 4, cos and secant functions are positive, the other functions are negative, that's the quadrant with letter C. We can start with the sine function. We will use SOHCAHTOA for the formulas for sine, cos and tan ratios. The formula for sine function is opposite over hypotenuse. Theta lies in quadrant 4, and in quadrant 4 sine ratio is negative. In the triangle, the side opposite the red angle is 7 units long, so the length of the opposite side is 7 and the length of the hypotenuse is 25. We cannot reduce this fraction, so this should be the final answer for sine function. Now we can write the value of cosecant function. Cosecant function is the reciprocal ratio for sine function. So the value of the cosecant function can be found by flipping the fraction for the sine function. I get negative 25 over 7. So this should be the final answer for cosecant theta. Now we can evaluate cos theta. The formula for cos function is adjacent over hypotenuse. In quadrant 4, cos is positive. For the red angle in the triangle, the length of the adjacent side is 24 and the length of the hypotenuse is 25. We cannot reduce this fraction, so this should be the final answer for cos theta. Now we can evaluate secant theta. Secant is the reciprocal ratio for cos, so we should flip the fraction for cos theta to get the value for secant theta. This should be the final answer for secant theta. Next, we can evaluate tan theta. The formula for tan ratio is opposite over adjacent. Tan ratio is negative in quadrant 4. For the red angle in the triangle, the length of the opposite side is 7 and the length of the adjacent side is 24. We cannot reduce this fraction, so this should be the final answer for tan theta. Next, we can evaluate cotangent theta. Cotangent ratio is the reciprocal ratio for tan, so we should flip the fraction we got for tan theta to get the answer for cotangent theta. This should be the final answer for the value of cotangent theta. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.